the past, I guess. All right. So which thing did you like the best? What was the coolest out of the announcements? 6 Plus. Why do you need 128 gigabytes in a phone?
I don't think you do. It's just cool.
You have a lot of music.
No, I can see that with music. Can you fill 128 gigabytes of music?
Oh, yeah, you can.
Yeah. See, I don't listen to music, so it doesn't. I don't think in those terms. And it seems like with video and everything now, you just stream everything, right? So I can only see any sort of real capacity being if you're going on a overseas plane flight or something. You need to put a bunch of episodes of some TV show on there, but chances are you're probably going to look at that on a tablet or something, an iPad. So I don't know, but I guess I could see music. Okay, which was the worst?
Apple Pay. It's a tie between Apple Watch and Apple Pay.
Okay, why do you think Apple Pay was crap?
Only 220,000 supporting it, so to start out with.
That's pretty decent.
And it's just like
I feel like it's going to be limited.
Okay.
Where you can use it.
Oh, it certainly will be. So the question is will it be? So it's certainly going to be limited day one, but will it end up taking off so that it becomes kind of a standard? That's the real question. If it becomes a standard, that could be kind of cool. But then do you have the situation where only people who, have one of Apple's payment-compatible products, can utilize it? But I run into the same thing at the gas stations when you have the ones that have the quick pass cards, you know what I'm talking about? I don't have one of those, but I always feel left out. It says if I have one of those, I can save like 10 cents per gallon or something. Okay.
it's also kind of a copy of a Google Wallet.
How so?
Because it's available for the iPhone already, and you just go up in your phone and they scan it, and then you use it for pay.
Well. It's still limited from the perspective they have to have the ability to scan it. That has a lot of. You're handing somebody physically your phone. They know who you are. Blah blah blah. So there's other. You're not anonymous in that case. So I think this isn't necessarily a copy of that. And this is a new infrastructure as opposed to a convenience pay.
Mm-hmm.
But so maybe an evolution. An evolution of that, I think, might be fair. Okay, and then somebody else said the watch. Thought the watch was dumb. Why did we think the watch was dumb?
You have to have the phone with you.
Okay. Why is that bad?
If you're using it for, the sport aspect, why would you want to have your phone in your pocket or somewhere on you at the same time?
And it remains to be seen whether you'll actually have to for every feature of the phone, or the watch rather. Certainly if you're, I would almost guarantee the thing will tell time without your phone nearby. But I'm guessing you'll lose any internet connectivity features of it. Yeah, but it's interesting from like the if you're going to use kind of like the stuff where it's collecting heart rate and whether you're going up and downhill and stuff like that. Do you need the phone there for that, or when you come back to your phone, can it tether and go ahead?
I also think it'd be kind of a waste of money because not a lot of people wear the watch, and then when they wear it, it wouldn't be that often, so it'd be a waste of money. I mean, because you don't wear watches that often, at least most people don't.
Yeah, it's something I've seen. I haven't worn a watch in about a decade. How many of you wear watches in here?
I used to wear them that often.
Yeah, so watches have kind of faded out some because people are now using their smartphones as their watch, right?
Yeah.
So does this give you enough reason to start wearing a watch again? Maybe. I think in the category, maybe the Apple Watch seems innovative and it could be kind of a cool thing. Will it end up being the player, or will it be more like a Google Glass, where the department has 2 pairs of Google Glass and they're really they're neat, but they're stupid. It's one of those things it's fun to play around with it for 15 or 20 minutes, and then it's like, okay, what would I use this for? They're not comfortable to wear. You constantly have to screw around with being able to see out of it and stuff like that, but it represents an evolution in wearable technology as where things might end up going. I mean, I think we could all, assume that if we fast forward 50 years, we're probably going to have contact lenses or glasses or something like that are going to have these things in them, and have it done right. And is this the early steps of that? So I think that could be kind of a neat thing. I thought there was kind of a subcategory of the watch that was the stupidest part. I am interested in the watch from how it will change the industry perspective, but I don't understand why they would come out with, there's like 3 different lines, and I don't understand the other 2, the sport, and I mean, it seems to me that should just be the difference between the band, whether you want a band that you can sweat through or, but whatever. But the last one, the whatever they called it, with the gold, that doesn't make any sense to me. So, obviously it's going to be more expensive. I didn't talk about the price, but to me it seems like this is going to be one of those categories where you're going to feel like you have to upgrade your watch every year to have the latest, greatest, coolest, whatever. You don't want to have to keep dropping $2,500 on a new watch every single year. It seems like you get the, you get just the stock Apple Watch, and this is the thing I wear for sports and crap like that to keep track of all the steps I take and all this other junk. I think there'll be a lot of cool health applications that'll come out of this. I think that might be where it really takes off, is more in the healthcare thing where people are getting monitored 24/7 by wearing the watch. So people almost wear the watch as like a medicine. I was telling the class yesterday, there's a company I work with called Cardiac Advancements that they make a product called the AFib Alert for a heart defect or a heart problem, so they want to create an app related to the watch that will like pre-detect a heart attack. Where the watch will, it's their algorithm stuff, like how they can tell whether or not you're going to be in trouble. But the idea would be that it would give you some sort of alert saying something's not right, go to a hospital or something like that. So I can see applications like that being interesting. But I don't see an expensive gold version of this being a great idea when, assuming it becomes a new product category, every year they're going to come out with the new features, the new faster processor, new detectors and stuff like that on it for reading other bodily functions and other things that are happening in the outside world. So you're going to have to constantly get this new watch. So I think that could be an interesting thing. So I actually maybe would have said Apple Pay was the best thing they announced. Something that they said that I thought was kind of interesting related to Apple Pay is lots and lots of places have come out with alternative payment methods, right? And even individual stores like Starbucks, you can go in and you can use their app to pay for your and reload your gift card and all that stuff. But each of these other payment options have always had the company that's come up with the payment options best interest in mind, because they're trying to make profit. They're trying to become the new standard or something like that and make profit off of it. So that was something interesting that Apple said where, as far as the things Apple said they're not collecting from this Apple Pay thing, they're not collecting the person's name. They don't know what they bought. They don't know how much they spent. They're just marrying the credit card companies to the merchants. So from that point of view, they're adding in a convenience. They're making their money because now there's a reason to buy Apple's product, but they're not making anything on the transactions. So at least seemingly not. So I thought that was kind of an interesting thing, that maybe it's a more altruistic approach, or at least they're going to make their profit in a different area of that. So, but an interesting announcement nonetheless. I did like the 6 Plus. It is funny though, as you watch the evolution of these smartphones. In the early days of the iPhone, Apple was very adamant about the correct phone size was the 3.5-inch screen. And then they came out with the 4-inch screen that was, a little bit bigger, blah, blah, blah. But, it's still, this is the correct phone size. And the problem with the Android world is that you have so many different devices with so many different screen sizes that the apps don't look as nice because you're having to design these apps that work reasonably well in all these different screen sizes. Well, now Apple's doing the same thing. So I kind of find that funny. And I'm a little torn from a developer's perspective. I write iPhone apps, and I know the headaches that it takes to write an app for different screen sizes. So it's already been created in the Apple world now between the iPhone 4 and the iPhone 5, 4S, and the 5, where it went to the taller screen. Well, now by default you have the little bars in the top and bottom of your apps, but now you can use those spaces. Well, so if you're going to write an app and you want the app to, if you want the app to look the best on all devices, you have to write one interface for the iPhone 4S and before, and another interface for the iPhone 5 and newer. Well, now you're going to have to write another interface for the iPhone 6 and newer to take advantage of even the bigger screen size. So it's, I think it certainly adds a level of, I think it benefits the consumer, but hurts the developer. And could hurt the consumer if the developers get lazy and don't create interfaces for all the different things. And it's not necessarily a lazy thing, because creating an interface for every single screen size is difficult. But kind of an interesting problem. But heck, I do most of my news reading and stuff like that on my phone, and I have a 5S, and I'd like to have a gigantic screen. I'm a big guy. I could fit probably an iPad mini in my pockets. So, so this whole, 5.5-inch screen, that's not going to be that big. My wife and I did cutouts of them. She found the 5.5-inch one wouldn't even fit in her the spot she has for her phone in her purse. So that one's out. The 4.7-inch one will barely fit. In my mind, I would like, who would buy the just the iPhone 6 when you can get one that has the word plus after it? Doesn't it plus mean better? How many of you are going to get one of the new phones? Okay, how many of you are going to get the 6? 6 Plus? Why the 6 over the 6 Plus?
I deal with phones every day. I don't like those. I don't like big phones. Like 5.5, I've dealt with them lots of times, and I don't like the screen size.
Okay. What's your complaint about it?
Too big. Texting and driving is very hard.
That's a star for the day. It's too big. Texting and driving is just too hard. It seems like it would still be pretty difficult on the 4.6-inch screen. Or is that just about right? You could text and drive with that, no problem?
I've used the Amazon phone, the new Fire phone.
Okay.
I've used that one before, and that one, it's easier to use. Like, it's easier to hold. And like, if I can get my finger across the screen, holding it on one side, that works for me.
Okay.
If I have two hands just to text, that doesn't work.
Well, I did think that one feature of iOS 8 that they talked about for the big phones was kind of stupid, where it was called Reach or something like that.
Oh yeah.
Where you double tap or something and it drags the whole screen down so you can reach to the stuff at the top without having to take one hand off of it.
I thought it was funny.
They claim that it's like really intuitive to use, but I don't know, it just seemed kind of, I don't know, it was lazy to me. But
I don't know. The only thing about iOS 8 that I'm excited about is the device syncing, like across the Mac, iPhone, and iPad, where you can like answer phone calls on all the devices. It's kind of different.
okay, yeah.
The Wi-Fi, you can talk on the Wi-Fi.
Yeah, that was neat.
It'll all come down to just how seamless that ends up working. Chances are when it finally is available, because it's Apple, it probably will be pretty seamless. The question is how quickly will it be available across all carriers and that kind of stuff. Yeah, I don't know. I just think about the different things I use my phone for. I've been an iPhone user since the first iPhone, and every year I've gotten the new iPhone. So I've worked with tons and tons of Android devices because my company writes software for those as well. And I couldn't use them on a daily basis just because I've gotten past that geeky stage where I just want the crap to work now. But I do appreciate the idea with Android that you can just do whatever you want. I do appreciate that aspect of Android. It's just not for me for my daily life. It would be more for me for like my hobby life. So I haven't had the pleasure of on a daily basis using the big phone because I've been married to the Apple phone sizes. And I use this for everything. I read all my news on here. I do Facebook on here. I don't even remember the last time I did Facebook on a computer. How many of you can't remember the last time you did Facebook on a computer? I mean, this is like the device you do it on, right? So I can see how a bigger screen would just be better for digesting that, reading that information and that kind of stuff. So I guess texting and driving didn't really come into play for me. I've used voice dictation now for that.
Mm-hmm.
So I don't even have to have the phone in front of me. My Siri will read me my messages, right? Which is always funny when you get a funny message. I have Siri read it to me, knowing it's a funny message. My wife or like my parents are in the car, and like Siri's reading back like profanity and stuff like that. It's pretty funny. All right. So interesting announcement. Excuse me. Interesting announcement. Yeah, we'll see. I'm going to pre-order my phone, I guess 2 a.m. tomorrow morning. So we'll see how smoothly it starts midnight tonight, but it's midnight Pacific time. So we'll see how smoothly the pre-order process goes. In the past, I have woken up at 2 in the morning and still been up at 5 in the morning, constantly refreshing, trying to get my order through, but we'll see what happens. I'm hoping to avoid having to camp out next Friday, but we'll see what happens.
Put the car in front of the store so nobody else
Yeah.
can park there.
Well, no, I mean, I do the crazy campouts. I'm always number one in line. Yeah, I have a problem. I'm getting too old for that, though.
Did you hear about the new waiting in line process?
Yeah, I posted on Facebook.
Yeah.
Yeah. Well, it doesn't change the waiting in line process because Apple doesn't hand out they didn't hand out the physical cards till the end. So it'd be nice if you got in line and they just came out and handed you your card and you could just leave, right? No. The way it works is you get in line at like 10 p.m. whenever, for instance, here Bayshore lets you line up around 10 p.m. And then around 7 a.m. they start coming around with the cards. At least that's what they've historically done. And then, they give you a little tag so that when it's your turn, you just hand them and they go and get you the item that you're going to get. Now they're going to do it where you can actually leave the line, do it all digitally. So they send you a text message with your item number or something like that. I don't know. I mean, it would be nice if you could just show up in line at 10 p.m. and, maybe at midnight, you come out and start handing out stuff. Make you wait a little bit, earn it, but I don't know if I want to pull another all-nighter. So
And then
hope,
teach on Friday.
huh?
And then teach on Friday.
Well, I've done that plenty of times.
I mean, you could buy like one of those huge like Alaskan tents and do, like,
They don't let you. They don't let you do anything anymore.
Really?
You can't even have a chair.
That's messed up.
Really?
Yeah, every single year they make it more and more restricted.
Not even a chair.
No, I mean when the first iPad was announced, I camped out for like 37 hours for it, and I wasn't even first in line. I was second, and we were sitting on the sidewalk, and we had like a coolers and all this stuff set up. Now, I mean, they have like roped off lines. They make you stand in. You can't bring a chair. The security guards are all like jerks. If you have a chair, you have to get out of line, and it's not a fun experience anymore. I think in a lot of places it might be, but at Bayshore they've really taken the fun out of it. I mean, in New York, you got these people that they've been camping out for the iPhone 6 before it was announced, right?
Yeah.
I think there's guys out there. They're sponsored by some company. They're handing out T-shirts and stuff.
There's also some in California.
Mm-hmm. So, could be kind of interesting. All right. Now, we had a homework assignment. If I remember correctly, you were supposed to count the number of odd numbers between 1 and a million. Okay, using a while loop.
Yep.
So, we'll create a variable. I start off at 1, while I is less than or equal to 1 million. Now we're going to create a variable for count. We'll start off at 0. We have found 0. Odd numbers? How do we determine if a number is even or odd?
Use the modulus function.
Okay. How would I use it?
Take first of all, you have to make a variable that equals.
Well, let's talk about modulus in general. Modulus is the remainder, right? So how do I detect whether a number is even or odd?
Oh, you divide it by 2, and if the remainder is 1, that makes it odd.
Okay, if we're divided by 2, if the remainder is 1, it's odd, right? So I'm going to ask a question. If my current number, I, when divided by 2, has a remainder of 1, I like to put the spaces in there. So I mod 2, equivalent to 1. That means that we have an odd number, right? And if we have an odd number, we're going to say count is equal to count plus 1. Add 1 to it. Regardless of whether I was looking at an odd number or not, I need I to be 1 greater than it used to be. So we initialize our starting variable for I. Well, you can call it whatever you want. I just named it I. Start off at 1. I is going to keep going as long as it's less than or equal to 1,000,000. Each time through this loop, I becomes 1 bigger than it used to be. So it'll be 1, then it'll be 2, then it'll be 3, then it'll be 4, so on and so forth. Each time through the loop, we will ask one question. We will say, is the current value of I, when we divide it by 2, does it have a remainder of 1? Which means that 2 did not go into it an even number of times, which means it's an odd number. Make sense? If that's a true statement, we're going to add to our count 1, because we just found an odd number. Make sense? After that loop's done, that means we've gone through all the numbers between 1 and 1,000,000. And we can print out count. Half the numbers, which makes sense, right? All right, so this would have been the way we would have done it if we wanted to be, let's say, mathematically sound, to actually ask the question. This would have been the way to do it, taking advantage of all of our tools that we've learned so far. We could have avoided that question and instead just always add 1 to count, but add 2 to I. Right? Because as human beings, we know that 1 is odd, 3 is odd, 5 is odd. So let's just count through the odds. And we'll just count the number of times we spun through. So that would have been acceptable as well. Go ahead.
Could you set it up where you count down from the high amount and you count the amount of processes, or the amount of time it goes through the loop? If you count down by 2, then you go down.
So as long as I is greater than or equal to 1?
I just did greater than. Because if you do equal to, then it can count the even process, which can change your number.
Well, if we're going to start I off at 1,000,000. So you would count backwards, right?
Yeah.
But you want to make sure that you count 1 as an odd number.
Yeah.
So we need to have the equal to.
Okay. Yeah, I just.
If we leave it out, I'll go ahead and leave it out for right now. So we'll say I is greater than 1.
I just did it on 0, so I mean, I guess it can.
Oh, you did greater than 0.
Yeah.
So greater than 0 is the same thing as saying greater than or equal to 1.
Yeah, because it's only ins.
Correct. So now we'll start off at 1,000,000. Keep going as long as we're greater than or equal to 1. Add 1 to count each time. subtract 1 from I each time. So exact same thing, we just went the other direction. We'll still get the same answer. Make sense? Okay. So that should have been a little thing to practice some of the things you had in your toolbox up to this point. So where we left off last time, we were talking about loops, and we introduced the while loop. We actually introduced the other loops, we just didn't look at the syntax for the for loop and the do while loop yet. So while loops lend themselves to problems where we do not know how many times we need to spin, right? It's kind of problems like press any key to continue. For loops lend themselves to counting type loops, which is what we just did, right? That problem we just did was a counting type problem, but we used a while loop for it. Because remember I mentioned something along the lines of any problem that involves loops we can solve with any of the loops, possibly having to use some if statements and things like that. Okay, and finally, do while loops are loops where the body of the loop needs to be executed at least one time. This while loop and for loops are both pre-check loops. We check the Boolean expression, this guy right here, before we execute the body of the loop. What's a Boolean expression? Any expression that boils down to a single value of true or false. So let's look at the syntax for a for loop. It's the word for, all lowercase, followed by an opening parenthesis, followed by a statement, followed by a semicolon, followed by a Boolean expression, followed by a semicolon, followed by a statement, closing parenthesis, opening curly brace, body, closing curly brace. That's the generic syntax. Now, this first statement here is often used for setting up the counter. So it might be something like int I is equal to 1. So here, look, let's call that statement 1. Let's call this statement 2. So statement 1 commonly might look like that. Define a variable, give it its initial value. Statement 1 gets executed exactly one time before anything else happens. So this guy happens exactly once. What is it simulating? This right here, which happened before the while loop started and happened exactly one time. In a for loop, this guy happens before we do anything else associated with the for loop, and it happens exactly one time. Okay? So it's almost like we're taking the pieces of the while loop and bringing them into the for loop's header. All right? So statement 1 looks something like that. Technically, excuse me, we could have multiple variables in there. So we could have said int I equals 1, int count is equal to 0, with a comma between them. I will say that you will rarely do something like that, but legally you can. Okay? And you'll kind of understand why you'll rarely do that here in a few minutes. Statement 2 is typically used to change the value of whatever you defined in statement 1. I is equal to I plus 1. Something like that. So what's it doing? It's simulating this part of the while loop. Typically, somewhere inside your loop, you're going to be changing the value that the loop is looping on, especially for counting loops. So it's simulating that, and typically this happens last. So orders of operation here, when the loop first starts, this guy happens exactly one time. Then, because it's a pre-check loop, we ask the question, the Boolean expression. If it's true, we execute the body of the loop. Then we execute statement 2, ask the question again. If it's true, execute the body. Statement 2, ask the question again. If it's true, execute the body, so on and so forth. As soon as this is false, we fall past the closing curly brace of the loop and continue on with the execution of the program. Make sense? So all the pieces of the while loop, the while loop we've written, is part of the for loop. It's just kind of all compacted into the for loop itself. So let's go ahead and let's look at the for loop equivalent of our homework assignment there. For int I is equal to 1, I is less than or equal to 1,000,000, I is equal to I plus 1. If count, if I mod 2 is equivalent to 1, that's a true statement. That means we have an odd number, and we'll say count is equal to count plus 1. After the loop's done, we'll print out count. So order of operation here, we define a variable named I, start off at 1. That happens exactly one time. Then we ask the question, is 1 less than or equal to 1,000,000? Yes, it is. Then we ask the question, is 1 divided by 2 have a remainder of 1? It does. Count goes from 0 to 1. Then increment I. I is now 2. 2 less than 1,000,000? Yes. Ask the question, increment I. 3 less than 1,000,000? Yes. Ask the question, increment I. 4 less than 1,000,000? So on and so forth. Less than or equal to 1,000,000. Is 1,000,000 less than or equal to 1,000,000? It's equal to it. So we'll ask the question one last time. 1,000,000 becomes 1,000,001. Is 1,000,001 less than or equal to 1,000,000? No. False. We fall past the end of the loop. We print out whatever the current value of count is. And count was hopefully modified inside of our loop many times. Make sense? So same result, but the solution to it was a little different. We used a different kind of loop.
So what exactly is the question, the IMOD 2 rules? Yeah.
So if we take 1, let's say I is 1. 1 divided by 2, how many times does 2 go into 1?
2 go into 1, 0.
0 times, with remainder 1.
Okay.
That means it's an odd number.
Okay.
So is 1, this side boils down to 1 in this case.
Okay.
Is 1 equivalent to 1? Yes. So add 1 to it. Let's say it was a 2. 2 divided by 2, how many times does 2 go into 2? 1 time. 1 times 2 is 2, with remainder 0. Is 0 equal to 1? No. So that's why it's even. Make sense? Okay. Let's see what. Oh, yes, this is what I was going to do. Why use a for loop over a while loop for counting problems? Well, really any problems. We want to look at some of the strengths and weaknesses. So I'm going to get rid of all this stuff, and we're going to look at a couple of examples. Oh, okay, well, I'll leave it like that first. What's the output of this program going to be? What will it be?
Remember it was less than 10.
Okay. Why?
It's less than.
Well, I create a variable named I. I starts off at 0, right?
Mm-hmm.
Is 0 less than 10?
Yeah.
Yep. So what's going to print out? 0. Spin back up. Ask the question again. So what's going to print out in this program? How many times? Forever. This is an infinite loop. These are bad. Okay? So I go to run this guy. It's going to run for a while. You're going to start recognizing, okay, something's gone south. Okay, so we'll stop it. What did we forget to do? We forgot to increment I. So now we'll say I is equal to I plus 1. Okay, now, what's the output of this program going to be? Go up to 9. So 0 less than 10, yes. Print out 0, 0 becomes 1. 1 less than 10, yes. Print out 1. 2 less than 10? There's 0 through 9. Make sense? All right, well, let's write the equivalent. I'll use J as my counter instead of I. So here's the equivalent loop in a for loop. So it should print out 0 through 9, then 0 through 9. Correct? 0 to 9, 0 to 9. Both loops do the same thing. Here, I'll put a little divider in here for a second. That'll just put a little line between our two outputs. What's the output of this while loop going to be now? I added one line to it. Nine twice. Well, trace through the code. Let's say I is currently 8. Is 8 less than 10? Yep. Print out 8. 8 becomes 9. Is 9 less than 10? Yep. Print out 9. 9 becomes 10. Is 10 less than 10? No. Fall past it. Print out the current value of I, which is what? 10. So this will print out 0 through 10. And we already know our second one prints out 0 to 9, right? So there's our 0 to 10. And here's our 0 to 9. So sticking with the example, what will print out there? 0 to 10 and 0 to 10?
Yeah.
Well, if I could run it, it's yelling at me, we have an error. And this is the difference typically between a while loop and a for loop in terms of problem solving. We defined J as part of the syntax of this for loop. So this variable J is a local variable that lives and dies with that for loop. So by the time we get past the for loop, it's never heard of a variable named J. Does that make sense? So if I hover over this, it has a little red mark. It says, cannot resolve the variable. Doesn't know about it. because J only lived inside the opening and closing curly braces of this for loop. Now, we can actually cheat it. We can say int J here, and then just give it its value there. Now J is defined outside of that for loop. So it's actually usable anywhere from here down inside of main. So now it'll work. There's our 0 through 10 or our 0 through 10. You typically would not do this with a for loop, but you can. Let's talk about that a little bit. That's actually a very important concept we just looked at. Something called scope. The scope of a variable. Where a variable is accessible. So going back to what we had here before, the scope of this variable J. Scope is always defined by where the variable is defined. So we look at the definition of J right here. That's where we give it its type, its name, and optionally its value. Okay, that's where the variable is being defined. Here, J is being used, not defined. Here, J is being used, not defined. It's only being defined once right here. That make sense? Variable definition versus variable use is an important distinction. And we've already seen it today. I mentioned it last week. Sometimes things are not what they seem at first glance. I've already tricked you, I think, at least once today, if not twice. When you thought it was going to print out 0 through 9 or 9 twice, you had to trace through it and actually see what does the code do. Your assumption, I'm picking on him because he's the one who said 9 twice, which is a perfectly reasonable thing to say. It's the answer I always get. The assumption was what? It would print out 9, and that would be the last time it's through the loop. But you didn't consider that the 9 actually became a 10. And that's when the loop actually failed, was the next time through when the loop failed. Does that make sense? So you do need to actually trace through your code and resolve everything. You'll get used to just looking at it, and you'll do that almost automatically. But that's what ended up happening. So that goes right back to what I said last week. Sometimes things aren't what they seem. We were saying that along the lines of the Boolean expressions. When you had these big, long, scary Boolean expressions that ultimately boil down to a single value of true or false. Okay. So this variable is defined here. Its scope is anywhere within the environment depicted by the opening and closing curly brace of this for loop. We think of scopes as being local to an environment. A variable environment is a collection of variable value pairs. And every Java program has a global environment. And within that, we have potentially multiple local environments. So if I look back here, we have a global environment. There happens to be nothing in it. Well, nothing that we know of right now in it. There actually is something in it. And that would be any variables defined inside of this opening curly brace for the class, but outside of the opening and closing curly brace for main. We can even use some tools in Eclipse to kind of show this. this is our program. Our program is a class with an opening and closing curly brace, and inside of this is a collection of class members. In this case, we have a single class member in here that is a method. It happens to be the main method. All programs begin and end with main. This is a global environment. We have no variables defined in here, but any variables defined in here would be available to main, because main also lives in the global environment, and would also be available to any other methods defined inside of the global environment, but not inside main. So eventually we're going to start writing other methods in here. We'll have more than one thing, not just main. Okay? So that's our global environment. Well, then we have a local environment associated with main. Inside this guy, we have a variable named I. So I is a local variable we defined inside of main, and its scope is anywhere inside of this opening curly brace from this point on, from where it was defined on. So we can't print it out before we defined it. It's not going to like that. Okay? So you have to define it before you can use it. But from this point on, inside of these opening and closing curly braces, we have access to this local variable called I, which also means we cannot define another local variable called I. It's going to say this guy's already defined. Duplicate local variable I. Now, if I want to change the value of I to 7, that's fine. It's a variable. Variables let us change it. So I just say I equals 7. There's no logic behind that right now, but I can do it. Okay, I'm not redefining the variable. I'm just changing the value of the variable. So variables can only be defined one time within a scope. Let me try to give you some more examples here. Don't worry about the word static here, just trust me. You'll learn about that later. Let's go this route. Oh, here, this will be a very interesting program to look at. What's the output of this program right now? We have a global variable named I that I set equal to 5. Okay? Then I come into main. Main then defines a more local variable called I, and it starts off at 0. I'm going to throw another fact in here. Variables always resolve to their most local definition. Okay, and we'll explain that here in a second after I trick you. So I've defined a more local variable, more local definition of I. I is 0. And here, just for the sake of argument here, I'll start I off at 50 up there, the global one. Well, I is less than 10. This variable needs to resolve. What value will it resolve to? Will it resolve to 0 or will it resolve to 50? Why? A variable always resolves to its most local definition. So this will resolve to 0. Is 0 less than 10? It is, so this will print out 0. Then we're going to set I equal to whatever I currently is plus 1. Well, which I will this change? Huh? The local one. Yep. It will always resolve to its most local definition. So we're going to take this variable I, well, which I is that? That's this guy. And we're going to take its current value and add 1 to it and store the result, assign the value, that's the assignment operator, the single equal sign, assign the value back to I. So that's changing this I. We haven't done anything with this guy at this point. Make sense? This guy's here to trick you. It's going to be really funny as I keep telling you it, I'm still going to trick you. This is where I get my enjoyment. All right, so this will print out 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Then we'll fall outside of the loop. We're going to print out I. Now remember, I did become a 10, right? The last time through this loop, we printed out a 9. 9 becomes 10. Is 10 less than 10? No. We fell past the end of the while loop. We're sitting at this line right here. Now we're going to print out I. Which I does it print out? Well, the correct answer is always its most local definition. The question is which is the most local definition here? So is this going to print out a 10 or is this going to print out a 50? Or is it going to print out a 0? That wasn't one of my original options, but I'll entertain it. It's not right, but if you want to go with it, it's cool. This guy started off at 0, right? But we changed him a whole bunch of times inside here. So he was only 0 for a second. Then he just kept changing. What's going to print out here? A 10 or a 50? 10? Willing to bet your grade on it? It'll print out a 10. Okay, this will print out a 10. Why? Why did it resolve to this version of I instead of this version of I? This version of I is local to this method main, not to this loop while. Make sense? Okay, so this will print out a 10. Then I'm going to change I to 7. Which I did I change to 7? This guy or this guy? The 10. I just changed the I that was 10, I changed it to a 7 now. For no good reason other than just to trick you. Again, trick you. Nothing up my sleeves. Yeah, I hope this trick works. Okay, then I just print out my line break. Now, I start with a variable j. It's going to print out 0 through 9, right? What's going to print out here? 7? Okay. Zero through 10, 0 through 9, followed by a 7. Where did this I come into play? I'm going to go ahead and take out our while loop. We're going to just deal with the for loop here. Now I'll change our variable to an I here. Now, I is equal to 7. Which I is 7? This guy or this guy? Global 1. So we just changed a 50 to a 7. Then we define a new variable I. I is equal to 0. Keep going as long as I is less than 10. Add 1 to I each time. This will print out 0 through 9. Which I are we changing here? Its most local definition, which is right here. When this loop is done, we printed out 0 through 9, then we're going to print out I. Which I will this print out? 7, the global variable, which we changed. That make sense? If we didn't change it, then it would print out the 50. Now, what's going to print out now? There is an error, but pretend like there's not. We changed I here. Which I did we change? The global one. Then we created a local variable I with a value of 5. This variable has a scope where? From here on, but inside of main, correct? Then we defined another variable I. Started off at 0. This variable has a scope of what? Just inside the for loop. So this will print out 0 through 9. What would we think would print out here? We would think it would print out the 5, the most local definition, correct? We do have an error here, though, as you pointed out. Duplicate local variable I. What does that mean? That means that this variable I that lives inside of this environment right here cannot be overridden by this variable I, which lives in this local environment here. But we were able to define this I in this local environment, which overrode this variable I in the more global environment. So we have a couple of different sandwiches in here. We have the global environment that has a variable named I in here. That's 50. Then we have a more local environment called main. And we are allowed to define a variable named I, which does what's called shadows this variable. Puts it on the back burner, because all variables result to their most local definition. Okay? So this is allowed. But then we have another more local environment. Seemingly the same thing as going from this environment to this environment, which was allowed. Then we went from this environment into this environment, and we could not create a more local variable. What does that tell us about for loops? The environments related to for loops. They must be a little different than the environments associated with methods. I would call this a weak environment. It does create its own local environment, but it actually is a sub-environment of its own local environment. So these two guys kind of live in the same world. The for loop recognizes things within its own environment because of the way a for loop is defined. This guy is a statement. This is the for statement. And when this statement ends, any variables that statement created and added to this local environment are deleted. It's not that they weren't there. It's just they're not there anymore. Okay? That's why these two conflict, because we're trying to define this variable I inside of the same environment that it already has a definition. But at the end of this for loop, let's say I get rid of this. And let's say I don't have this, which means that's no longer legal. At the end of this for loop, if I just try to print out I, it's telling me I don't know about this variable. Because at the end of this for loop, when this for loop died, it went and removed the local variable I from that local environment. That make sense? Okay, so variable scoping is very important. It can be very confusing until you get used to it. Okay. For loop versus while loops. Now, syntax for a do while loop. It's the word do, followed by an opening curly brace, followed by the body, followed by a closing curly brace, followed by the word while, followed by an opening parenthesis, followed by a Boolean expression, followed by a closing parenthesis, followed by a semicolon. And this is all case sensitive. So the word do, no spaces, all lowercase. While, no spaces, all lowercase. And it must have a semicolon at the end of it, which is the only loop that has a semicolon at the end of it. And you need to be careful with that, because if you accidentally put a semicolon at the end of one of your other loops, bad things happen. In fact, actually, this is an interesting bad thing. I put a semicolon right here. This guy says, I don't know about the variable I. It's the for loop. Lived and died right here. And at the end, it deleted I from the local environment.
And that comes out blank.
So it doesn't know about it. There's an error right here. So if I left this out, here, let's so I'll define a variable named count, start off at 0. Here we have our for loop. Loop's going to go I is 0, I is less than 10, add 1 to I each time. Each time through, we're going to add 1 to count. Count becomes 1, then 2, then 3, then 4, then 5. And then at the end, I'm going to print out count. What's the output going to be? It's going to be 0. Why is it 1?
Because you plus 1 of count.
It executed that line of code. Why? Yeah, this guy has nothing to do with the for loop. We just put some extra curly braces in here. So this is just a block statement. This line, what we did here is equivalent to this. It's equivalent to that program. Which you would never write code that looks like that. But it technically is legal. A block is something that's surrounded by opening and closing curly braces. And it's just a collection of statements. Okay? Usually we associate blocks with methods or loops. But a block could just stand on its own, but it never would. There's no reason for it. Blocks exist to supplement or to support loops and methods and conditionals. Okay, but it did trick us here. We had a for loop, but the loop had a semicolon at the end of it here, which was a mistake. And that semicolon kept us from executing this block as part of the loop. We still executed the block because this loop lived and died on this single line right here. Because that opening and closing curly brace is not required in loops, just like it wasn't required in if statements. Remember we talked about that? It's never wrong to have an opening and closing curly brace, but it's not actually required.
So for for loop, do you need to have that second statement in there, or can you throw that second statement into that black text there, the I equals I plus 1?
You actually can leave both of these blank if you want, and just put everything inside here. Kind of defeats the purpose of the for loop, but you could. Now, if I take the semicolon off there, now it'll count through. Because now that block just became part of the loop and was conditionally executed depending on how the loop spun through. Make sense? All right. For homework, I'll put an angel here in a second. Write a program that counts the number of numbers between 1 and 1,000,000 that are evenly divisible by 3, 6, 9, and 12. So the number of numbers between 1 and 1,000,000 that are evenly divisible by all 4 of those numbers. That make sense? Not any of them, all 4 of them. Can you think of one number that's evenly divisible by all 4 of those? Okay, write a program to calculate it. I'll put it up on Angel now.